Good morning, children. Today let me explain you how to write the sample space when you toss the coin one time, two times, three times or n number of times using a tree diagram. This tree diagram is very useful for you to write the sample space. Now this is the tree diagram which helps you to write the sample space when the coin is tossed one time, two times and three times. Like this we can make it for n number of times. So first let us see how to write the sample space when the coin is tossed one time. So when the coin is tossed one time, you are getting one head and one tail. Now I am going to make the branches from this head and write it as head and tail over here. Again from this tail I am going to make this branch and then write it as head and tail. So when you toss the coin two times, you are getting head tail and head tail over here. But how will you write the sample space? You will be writing HH, HT, TH and TT. So you'll be getting four sample spaces. First, when it was tossed once, you got two sample spaces, and after making the branch from one H, that is H and T, and from T again one H and T, you are getting the sample spaces. Start from this head, so you'll be getting HH and HT. Again you start from this tail, so you'll be getting TH and TT. Now let us continue these branches and make it again from this head as head and tail, and again from this tail as head and tail, again from this head as head and tail, again from this tail as head and tail. So when you toss the coin for three times, the sample spaces, now you have to start from the beginning. Head, head and head. This is the first sample space. Second sample space will be head, head and tail. Now come over here, head, tail, head and head, tail and tail. Coming over here, tail, head and head. Here tail, head and tail. Coming over here, tail, tail and head. And the last one is tail, tail and tail. So always start from the first head and complete the whole branches over here. In this way, using this tree diagram, you can write the sample space very easily. Now, let us recap what you learnt in this chapter. First one, a probability P of E of an occurrence of an event is given by the formula P of E is equal to number of favorable outcomes divided by total number of outcomes. Second one, the probability of happening of an event always lies between 0 and 1. That is, your answer will always lie between 0 and 1. It will not be less than 0 and it will not be greater than 1 also. Next, if P of E is equal to 1, then the event E is called a sure event. That is, if you are getting the answer as 1, that event you call it a sure event. Example, if I say the sun rises in the east, this event happens surely. So that means the probability will be equal to 1. Next one, if P of E is equal to 0, then the event is called as an impossible event. Example, if I am asking for the number 7 in a dice, is it possible? No, it is not possible. So in that case, the probability of an event will be equal to 0. Next, if A is an event associated with a random experiment, then the event not A, that is which is not happening, is denoted by A dash. So we can write P of A, that is the event happening, plus P of A dash, that is the event which is not happening, is equal to 1. As we know, the total probability is always equal to 1. Now, in order to find P of A, I can also write P of A is equal to 1 minus P of A dash, and P of A dash is also equal to 1 minus P of A. So you can use this formula to calculate whether the event is happening or whenever the event is not happening over here. This formula is very useful. This formula already we are used in different videos also. So you can go through this formula and also recapitulate all these points. These points will be asked in MCQ questions.